In this video, we will learn how to convert the general equation of an ellipse to its standard form. Similar to our lessons about circle and parabola, we will also apply the completing the square method and the formulas for square of binomials to convert the general equation of an ellipse with center at h, k to its standard form. Please take note that the general equation of a horizontal ellipse has a, the coefficient of x squared, less than c, the coefficient of y squared. This is its standard form when converted. We know that if a squared is the denominator of x, we have a horizontal ellipse. Now, if a, the coefficient of x squared, is greater than the coefficient of y squared, which is c, we have a vertical ellipse. If we convert this to its standard form, it will be like this. This is a vertical ellipse since a squared, the square of the semi-major axis, is the denominator of y. Let's put into practice what we know so far. Let's change the general equation of an ellipse, which is 3x squared plus 4y squared plus 24x minus 16y plus 52 equals 0. Similar to our previous lessons, in order for us to perform completing the square, we first need to group our equation according to its variables. If we follow this step, we shall have one group for x variable and another group for y variable. Then, we will transpose the constant term to the right side of the equation. In the second step, we need to make sure that the coefficient of x squared and y squared are both positive 1. Therefore, we will get the common factor of positive 3 and positive 24 that can make the coefficient of x squared equals positive 1. Their common factor is positive 3. Therefore, we will rewrite such group as 3 multiplied by the quantity x squared plus 8x. We will do the same for the y variable group. Positive 4 and negative 16 are both divisible by positive 4. Hence, we can rewrite it as 4 multiplied by quantity y squared minus 4y. We can now perform completing the square because the coefficients of x squared and y squared are both positive 1. We will take the half of the coefficient of x, which is positive 8, and we will square it. We have positive 16. Now, taking the half of the coefficient of y, which is negative 4, we have negative 2. Squaring it, we have positive 4. Afterwards, we will add 16 and 4 to the left side of our equation, while we will add 48 and 16 to the right side. Here, similar to our lesson in parabola, we need to multiply the resulting value by the common factor before we add it to the right side of the equation. This is because we factored out positive 3 and positive 4 so we can perform completing the square. Now, let's simplify the right side of our equation by combining negative 52, positive 48, and positive 16. Their sum is positive 12. In step number 5, we will express the two perfect square trinomials in the left side of the equation to square of binomials. Since x squared plus 8x plus 16 is of the form a squared plus 2ab plus b squared, we will use quantity a plus b squared to convert it to a square of a binomial. If you find the use of square of a binomial formula confusing and difficult, you are encouraged to follow or perform a strategy you are more comfortable with. As you can see, a squared corresponds to x squared. Therefore, if we get the square roots of both sides of the equation, we will be able to get the value for a, which is x. Therefore, a equals x. Now, b squared corresponds to 16. Getting the square roots of both sides, we have b equals 4. Therefore, b is 4. Now, the square of a binomial of x squared plus 8x plus 16 is quantity x plus 4 squared. We will do the same in our second perfect square trinomial. However, we will use the other formula. This is because y squared minus 4y plus 4 is of the form a squared minus 2ab plus b squared. For such, we will use the quantity a minus b squared. We can see that a squared corresponds to y squared. Then, square root of a squared and y squared are a and y respectively. Therefore, a equals y. Now, b squared corresponds to positive 4. The square root of b squared and positive 4 are b and 2 respectively. Hence, we have b equals 2. Now, we will replace y squared minus 4y plus 4 by quantity y minus 2 squared. In step number 6, we will simplify our equation by making the right side equals to 1. To do this, we will divide all its terms by the numerical value in the right side, which is 12. 3 multiplied by the quantity x plus 4 squared divided by 12 is 1/4 multiplied by the quantity x plus 4 squared, or simply quantity x plus 4 squared all over 4. Now, simplifying 4 multiplied by the quantity y minus 2 squared all over 12 will give us quantity y minus 2 squared all over 3. Lastly, 12 divided by 12 is positive 1. Therefore, the standard equation of the given ellipse is quantity x plus 4 squared all over 4 plus quantity y minus 2 squared all over 3 equals 1. Since the denominator of x is greater than the denominator of y, or 4 is greater than 3, therefore, the ellipse is horizontal. Its center is located at -4, positive 2 of the Cartesian coordinate plane.